Okay, this is for 5.5 for 161, property of logs. So now that we've done a little of the basics of logs, here are some of the properties that we can use to do some of the more complicated problems. So to keep in mind that when you have the log of a certain base of more than one thing being multiplied, if it would be helpful, so for now we're just going to practice it, but at some point it might be helpful to split it up into two separate logs being added. So you're always allowed to do that if there's things being multiplied, you can separate it. So same thing, if you're doing the log of a base of two things being divided, you can split it up into the log of the one minus the log of the other. If you have a log of something to a power, you can bring that power out front. And then we saw this in the last video, that if you have a log of a base to the same number, basically that wipes out and you have just x. Same with this type of thing. And then log of any base of 1 is 0. So we'll refer back to those. But for now, something like this, telling us to simplify this, remember ln e is the same as having the log of the same base, because ln really is log base e. So ln and e wipe out, so you're left just with whatever the exponent is. Number 2, these wipe out, you're left just with 6. And number 3, and here the ln and e wipe out, you're left just with the exponent, which if there's nothing there, remember it's a 1. It's not a 0, it's a 1. Okay, so for number 5, use the property of logs to find the exact value, no calculator. So I could do this right now in a calculator, but without the calculator, I don't know off the top of my head what log base 2 of 10 is, because it's not something nice. But I could rewrite this using the laws I just learned, as instead of two separate logs, I could write it as one log of the 10 divided by the 5. And since 10 divided by 5 is 2, I now have the log of 2 base 2. So all of that wipes out, and I'm left with just the exponent, which is 1. So same thing here. I can rewrite these two logs that are subtracted as just one log with division. And now since I have a 7 and a log 7, those wipe out, and I'm left just with the 1/4. So 7 and 8 are similar if you want to pause and try those, but then I'll do them so you can check. So I can rewrite that with division. 6 over 2 is really 3. So log base 3 of 3 is just 1. These two logs being subtracted, I can rewrite as one log with division. And then 6 and log 6 wipe out. So we're left with just the 3 over 8. And then something like 9 saying simplify express powers as factors just means we don't want an exponent. So if there is an exponent, move it out front, because now it's a factor, meaning now it's being multiplied instead of being an exponent. So that's all I would want you to do for something like this one. Okay, number 10, write as a sum and or difference of logs. So instead of it just being one log of multiple things, separate it into multiple logs using the adding and subtracting tricks. So right now we have one log, it's ln, but that's still a log, of this stuff divided by this stuff. So I can rewrite that using the subtraction trick, that I could separate it into subtraction. But then I can even go one step further because I see an ln e, which I know wipes out. So I can simplify this to this. Okay, same thing with 11. Just instead of one log with stuff being divided, I have stuff being multiplied. So that's going to change to this one plus this one. And then I don't usually want to leave the exponents at that point, so I'll bring the 5 out front and the 4 out front. And that's as far as I can go. Oops, I think I wrote that as a U. This one was a V. Okay. So again, if you want to try 12, same idea. And the only reason it's adding this extra stuff at the end is just because it's letting you know that nothing bad is happening. The denominator is never 0. I'm never taking a log of a negative. So you can kind of ignore this. It just has to be there to let you know that that's the domain, basically. Make sure you use parentheses when it's more than one thing. And there is no rule of one log being subtracted. So if it's something like x minus 3, you just have to keep that together. So this is basically my answer, except I do have an exponent that I could bring out front. So that would be as nice as we can make it. So one more, just a little more complicated. So make sure you're careful. Remember that 4x is not one term. So you need to do the ln the 4 plus ln x plus ln of this square root minus ln of this stuff. And then powers go out front. And remember that a square root is really a power because the square root of x is really the same as x to the 1/2. So when you have a square root, that's like all of this to the 1/2. And ln x is just ln x, sorry. Okay, so for this square root, I'm going to bring that 1/2 out front. But that's all I can do with that one. And with this, I'm going to bring the 9 out front. But then that's all I can do with that one. So that's my final answer. Okay, so that was writing logs as a sum or difference. Now we're going to do the opposite. They're going to give us logs as a sum or difference, and now we're going to condense them into one log by basically using multiplication and division. Okay, so for 14, and make sure in order to do this, they have to have the same base. So because these are both log base 5, I can write it as 1 log base 5 of this first thing divided by the second thing. And then in this case, since these are both x's, I can reduce this a little further, remembering that when you divide exponents, you really subtract. So off on the side, this is basically like x to the 1/2 over x to the 6. So I can do 1/2 minus 6, which is really the same as doing 1/2 minus 12 over 2. I'm basically just getting my common denominator. So that would be negative 11 over 2. So all of that can be reduced to just x to the negative 11 over 2. And then remember that we want powers out front. So the reducing for some of these is going to get a little tricky, but the main idea, hopefully, you're fine with that because these were 2 logs with subtraction. I could put it together as 1 log with division. If the rest of it was a little tricky, we can work on that. Same thing with 15. Hopefully the first part will be easy, but then it's just the reducing might get a little tricky. So this is the same as ln of this first thing times this second thing, but then divided by this third thing. So instead of dividing, I'm just going to do times 1 over, since we got a lot of fractions here. So now all of this can probably be reduced some, right? So first of all, the x's can be reduced because I have an x on top and an x on the bottom. These cannot be reduced because x plus 1 is not the same as x minus 1, but this can be factored to x plus 1 and x minus 1. So now I'm going to factor that. And so what do I have left? I have a 1 on top, and I have an x minus 1 and another x minus 1 on the bottom. Okay, so this is as simple as we can make it, but since we usually want to have it with an exponent that we can pull out front, remember that this would be the same as this because x minus 1 to the second on the bottom is the same as bringing that to the top and making it a -2. So then finally we could bring that -2 out front. So again, I understand the reducing is a little tricky, but hopefully the main idea of instead of these separate logs being added and subtracted, we can change it to multiplying and dividing. Then we can work on the rest. Okay. The last new thing is the change of base formula, which sounds fancy, but all it means is if you're trying to do the log with a base that is not 10 or e, then you're going to have to do something a little fancier than just putting it in the calculator. Because in the calculator, when you use the log button, it means log base 10. And when you use the ln button, it means log base e. So if you have something else, there's another way to do it. So if you have the log of any base, you can rewrite it as the log of this number divided by the log of that number with any base you want. So obviously you're probably going to pick log base 10 or ln because those are things we can do in the calculator. So here's an example. Log base 5 of 30, since we can't just stick that in the calculator as is, we can rewrite it as log 30 divided by log 5, which means we're basically making them both base 10. And so what is that? Well, let's put it in the calculator and find out. So log 30, see how it automatically did that parenthesis? So I'm going to end that parenthesis and divide it by log 5. It's not going to be nice, so that's why I said about instead of equals, and I'm just going to round it to 3 decimals. So I think that's what it says in the homework, but read the directions in the homework to see what to round to. So in this case, that would be 2.113. Okay, so this is just really practice using the change of base formula and then seeing if you can put it in the calculator correctly. So definitely get out a calculator and try these real fast. So first of all, you can rewrite this as log 20 divided by log 4. And again, instead of equals, because we're definitely going to round, I'm going to put about. That's what the squiggly lines mean. It means about. So again, log 20 divided by log 4. Make sure you end that parenthesis before you do the second log. So this one would be about 2.161. So make sure you're okay on your rounding. Do you see why I had to round that third decimal to a 1? Because it had a 9 after it. So this one would be log 9 divided by log square root of 17. This one would be log 7 over log e. So try those and see what you get. Just to make sure you're putting everything in correctly and using your parentheses correctly. Remember your E button is on the calculator as well. Okay, so definitely try these. Don't just assume that you'll be able to do them. Make sure. All right, and just as a review, the graph of y equals log base 5 of x plus 3 is the graph of log base 5 of x moved 3 to the what? So since it is inside the function, it's going to be left or right, remember? And it's the opposite of what you think. So plus 3 would move it 3 to the left. Okay, so here's your first kind of taste at using some of these properties to rewrite some of these problems. Again, right now, why are we doing it? Just to practice it. But soon you'll be actually solving an equation and you'll get stuck in one form. And so using some of these properties will help you rewrite it in a way that you can keep going and solve the equation. Okay, good luck. Try the homework and see what you think.